Hi everyone! So today we are going to talk about word problems that follow a sinusoidal model. Now sinusoidal, that's just a big fancy word, which means either sine or cosine. So the equation that we write will either be sine or cosine, just depending on the picture. The most common word problems that you find with these are Ferris wheel problems, tides, like high tide, low tide, the vibrations of a tuning fork. I've seen a few of those. Also heartbeats. They can follow a sinusoidal curve. The most common one that I always see though is Ferris wheel, so that's the first problem I picked for today. The first thing is to draw a graph, even though our ultimate goal is to write the equation. And on this graph, the most important thing is to figure out the highest and lowest points on the y-axis. Now, I see them mentioning time in the problem. They say something about 1 revolution every 24 seconds. Time always goes on the x-axis, so let's just label that. So that means that the other numbers that they talk about, like the person being 50 feet above the ground, that is on the y-axis. So this is the height over here on the y-axis. And we just highlighted that. The highest the person gets is 50 feet, so let's mark 50 right here. And then they didn't tell us the lowest. They kind of do this quite often in these Ferris wheel problems. They told us the diameter of the Ferris wheel. So let's think about this. Here's the Ferris wheel. If the total diameter is 44 feet, that's this distance here. But at the same time, the highest that the person gets when they're up here is 50 feet from the ground. So here's our ground down here. That must mean that this little part here is 6 feet, because that's the only way that this total could add up to 50. So that person who's on the Ferris wheel, the lowest they ever get to the ground is 6 feet, which is a good thing because we wouldn't want them crashing into the ground every time the wheel made a turn. So the highest is 50, the lowest is 6. Now, if you think about it in real life, so they would get on the Ferris wheel, so right when time is 0, they would be 6 feet above the ground. So that's 1 point on the actual curve. Then since 1 complete revolution happens in 24 seconds, well, that would tell us that when time is 24 seconds, they would be back at their lowest point. Now everything would be symmetric, so that would mean halfway along at 12 seconds, they would reach their highest point, which would be up here. And this is really all we need to create the equation of the graph. I can mark the halfway point, halfway between 50 and 6. If you can't just look at that and know what it is, one way you can compute it is just take 50 plus 6 and divide by 2 to get the average. So that's going to end up equaling 28 when you do the math. So this halfway point is 28. And then a lot of teachers have you draw the sinusoidal axis through there. So here's what the curve will look like. It'll kind of go like this, and then it'll come back down again. All right, so now we know we have to write an equation for this. Well, you should have been doing this quite a bit in your class. So the shape of this curve is a negative cosine, because positive cosine looks like this, and our curve is just completely flipped over like that. All right, I'm just going to get rid of that. So we're going to use negative cosine as our equation. Now the amplitude is the distance from the halfway point, like right in here, halfway point to the lowest, and that's a distance of 22, or it's the same thing up here too. Either way you look at it, the amplitude is 22, and I'm going to put the negative in front of that. So let's give ourselves a little more room. So negative 22 cosine, we already said. Now the next thing to come in the equation is the b, and b is always 2 pi divided by the period. And the period is 24. So 2 pi divided by 24, which reduces to pi over 12. That is going to get placed right here, pi over 12, times x, and then we would put the horizontal shift in the parentheses with x. Now since we used a negative cosine, there is no horizontal shift. So it's just going to be, we don't really have to write anything, but I'll put x minus 0. And then the final number is always the vertical shift, which is always in the location of your dotted line right here, which was at 28. So that's going to make it plus 28 at the very end. And so then let's just rewrite it without the minus 0 in there, because you really wouldn't put that. So negative 22 cosine of pi over 12x, and then plus 28. So this would be the answer that they're looking for. There are other answers, like if you went with a sine equation instead, then it's shifted to right here. So if you did a sine equation, here I'll just jot that down. A lot of it would be the same, but it would be a positive sign. So just 22 sine pi over 12 still. And then it's shifted to the right. That point would line up with right between 0 and 12. So it would be shifted to the right 6. So you would have x minus 6. And then there's still a vertical shift. So that is going to go off the screen a little, but I'll move it. So that will be plus 20 plus 28. And let's just move that whole answer so you guys can see it. So that right there, this would be an alternative answer. Another, I'll just jot down another okay answer. So it's kind of your choice if you choose to write a cosine curve or a sine curve. So now let's look at our second problem. This one I picked a tide problem. So again, we want to try to get a graph going of the highest and lowest points. So high tide, if you read through this, high tide is occurring at 4 a.m. and is 23 feet above sea level. So remember, we said before time is on the x-axis, and my other numbers are talking about feet above sea level. So let's just say, we'll just label this feet for the y-axis. So high tide is 23 feet, so that's going to be our highest point. And if you keep reading, low tide is happening at a different time, at 10:22 a.m., and it's 3 feet. So 3 feet is our lowest number. And I could right away just get the halfway point in between those. If we just do the average again, 23 plus 3 divided by 2 is 26 over 2 is 13. So 13 right here is going to be the dotted line, the sinusoidal axis. Okay, now the x-axis time, this is a little tricky. I did this problem on purpose to show you how to deal with clock time. So t equals 0 is supposed to represent midnight. So 4 a.m. would just be nice and simply a 4 right here. And that's where high tide is occurring, so we could put a dot right there. Now low tide is at 10:22 a.m. Well, just temporarily I'll put it 10:22 right here, but we can't leave it like that. So to convert it to not an hour and minutes, we can just convert it to a decimal hour. What you do is you take 22 and you divide that out of 60. 22 minutes out of 60. So let me do that real quick and we'll... Okay, so I did it on the calculator. That's about 0.37. All right, so I'm going to change this 1022 right here. I'm going to change it to 10.37 like that. And that's going to be where low tide is happening. Now the last high tide, because we need one more maximum on here to have a complete picture, I could just find the distance between 10.37 and 4, which is, if you subtract those, it's 6.37. So then if I just add 6.37 onto 10.37, that'll give us our ending point. So I just did that on the calculator. It's 16.74. Okay, so this gives us one complete period of high tide, low tide. And now what we can do is start to create the equation. To me, this looks like a perfect time to do cosine, because it's starting at the high point right here and then going like that. That's exactly what cosine looks like. It'll have a shift, but that's fine. So this, I'll just say, looks like cosine. So I'm going to have y equals the amplitude. Now this right here, or this right here, is amplitude, which in our problem is 10. So 10 cosine. Now, the next number that goes right here, we always have to do 2 pi over the period, which in our problem is 2 pi over the period is the ending minus the beginning, 16.74 minus the 4. So that is going to, you can use a calculator for all of this, but it's going to be 2 pi over 12.74. Let's just write it like that, because we could just put it just like that in the equation. 2 pi over 12.74 times, and then x, and we put the horizontal shift in the parentheses with the x. Now if you notice, the start of the cosine curve was here, so it's been shifted to the right 4. So we're going to write x minus 4. And then the final thing is the vertical shift, which is always your dotted, it's always the dotted sinusoidal axis, which was at 13. So we're just going to add 13, and that's our vertical shift, and this is our final answer. And looking at this, I don't think anyone would really choose to do a sine curve for this, because that would take extra work where you'd have to find like right where that's starting, and that would be a decimal between 4 and 10.37, so let's not even bother with that. I think the best choice for you for this one is just this answer, which is the cosine curve. So just remember, the key is to draw a picture, get the maximum and minimums on there, and that will lead you to be able to find the period, the amplitude, and then the shifting if there's a horizontal shift and if there is a vertical shift. And that's it.